Hi, and welcome to episode 15 of my free Java video course. My name is Markus Biel. Today, I would like to talk about exception handling in Java. So, first of all, let's have a look at some theory and some background information about exception handling. And then later on, we will, as always, directly jump into my IDE and I'll show you how to do exception handling in practice. Okay, so as you see, this is the Wikipedia article about exception handling. So first of all, let's have a short look at the definition. So here this article says exception handling is the process of responding to the occurrence during computation of exceptions, anomalous or exceptional conditions requiring special processing. Okay, let's stop here. Let's digest that. So, I think what is very important is two things. First of all, it is about exceptional conditions, because in my opinion, this is something that many programmers get wrong. I mean, an exception is called an exception because it should handle exceptional conditions. So the question really is, what is an exceptional condition? Well, in my opinion, an exceptional condition is something that really, as the name implies, only happens exceptionally, which means only really rarely, only in very specific situations, and those situations are anomalous. So, for example, programming errors. When you program, you introduced a bug, you forgot to, like you have an array and you have one field that is empty, and I talked about that means it has a field that is set to null, and then when you try to access this field, that, for example, can throw a so-called null pointer exception. Well, that would be really an exceptional case which you wouldn't have guessed it would happen, and yeah, that would be one reason for an exception. So exception handling is really the, as it says here, process of responding to the occurrence of exceptions. So something exceptional happens, and then we need a way to react on that, to handle that. Some special processing, which is not the normal program flow. But the cool thing about, this also is said here, often changing the normal flow of program execution. Because ideally we want like a central place that handles the exceptions, and so we want to leave the normal program flow and we want to just specifically take care of this exceptional case. Okay, and here it continues. It is provided by specialized programming languages, which gives us a hint it is not provided by all programming languages. Well, let's have a look at the history, which should tell us, software exception handling developed in Lisp in the 1960s and 1970s. Well, I think the first programming language was invented by Konrad Zuse in like 1943 or something. So you see, it took a while until they finally came up with the idea of exception handling, that something like this is really necessary. And well, maybe a bit more about the history and Java, because again, with Java there was something new introduced, and that is checked exceptions. Before, all exceptions were unchecked, which means any line of code can throw any kind of exception, and there is no mechanism that forces you to handle it. If you don't handle it, that, for example, causes the program to stop. And well, therefore, as soon as exceptions were like introduced, many times nasty things happened. And so when they invented Java in like 1995 or something, they thought, well, maybe we should do this a bit better. And well, first of all, let's have a look. Checked exceptions. Yeah, the designers of Java devised checked exceptions, which are a special set of exceptions. Here. Okay, and to make it short, so what's the difference about checked exceptions? Here's also already an example, an IO exception, which happens when there is a problem with an IO operation, input-output operation. The difference with checked exceptions in Java is they must be declared explicitly in the method signature or be handled. If you don't do that, you will directly get a compile time error, which means you're not able to even compile your program. I looked it actually up. I think it's here. It's quite interesting, like how it came with the checked exceptions. The Java programming language introduces the concept of checked exceptions. Checked exceptions must be handled in a method, or the method must declare the exception in a throws clause. Now it continues. I think here it's even more interesting. According to Anne Woolrath, who was there at the beginning, the credit for the Java exception scheme should mostly go to Jim Waldo. And then they go on, and here, after some consideration, Java was retooled to have checked exceptions. Only those exceptions for which there was no recovery or reflect application errors would be unchecked, and the world was safe again. Well, so they thought. Now, in the meantime, it's 2015, which is like 20 years later, and it turns out that was not so smart. Because the problem is, and this is also why I stated it at the beginning, maybe we should go back to the very top. Exception handling is the process of blah 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 exceptional conditions. And this is the important part, because they had the idea to have still unchecked exceptions for something like programmer errors, for something that is, as the name implies, exceptional, and to have the checked exceptions for everything else. But now I ask, why have checked exceptions for these cases that can be handled? Why not, if you can handle a specific situation, why not then instead validating that situation and not at all throwing an exception? And also, and now maybe we should directly jump into the IDE, because I guess it goes too far, too much theory. Let's directly jump into the code. So yeah, so here you see an enum that I've written, car state, with the different states: driving, waiting, and parking. I've written this public static from method that converts a string to a car state using a switch statement. I told you in a previous episode that since Java 7 it's possible to use a switch inside, to use a string inside a switch, and I warned you not to do it. This still applies, but in this case I assume that we're getting input from the console, and input from the user coming from the console cannot be an enum, must be a string. So this is, I mean, for every rule there is an exception. So this is an exception to the rule, which is here we do have a switching on a string. But now here we have the default case, and I also told you I would only throw exceptions in the default case, so that it cannot happen that someone adds a new state, and this new state would then be handled by the default case without anyone noticing, to have the fail early principle. And so I told you to throw an exception, but I didn't show you yet. Well, we can do this now, and this is quite easy. You can just say throw new exception, because an exception in Java is just a class like almost any other class. Well, it has some specific methods and stuff, but at least it's a class, and we can create objects from it. Now you already see a checked exception in action, and you see how the compiler already warns me unhandled exception java lang exception. So this is also the package java lang exception, and yeah, this is the number one checked exception. Don't ask me why it's called exception. If it's actually a checked exception, something like a checked exception, I mean the name was not used within Java lang. So you just have to know that this exception is a checked exception, and on top the default unchecked exception is a runtime exception. This, sorry, also not my fault. This also you have to know. I mean, runtime makes sense because something that goes wrong at runtime. And so you would normally use a runtime exception for things where you don't know how to handle them directly. And the idea was, as I said before, to have a checked exceptions for cases where you know how to deal with them. But as I said, if you know how to deal with them, why not dealing with them without throwing an exception beforehand, using validation? But anyway, let's continue. So how can we fix that compile time error? One reason is add exception to method signature. Let's use our IDE to help us, and here it adds throws exception. Now you see the compile time error is gone, nothing is read anymore. It seems like we fixed the problem. So we told the Java compiler, we know there is a checked exception, we just don't care. The caller should take care of it. And now I have this car service class here, and I made it to use the static from method that I implemented, and you see now this class has the problem. Okay, again, let's do the same thing. Add exception to method signature. Okay, and I guess you know where this leads to. Now we are in the main method, and again we have the same problem. Well, we can annotate. This is all the wrong stuff. Seems like we're on the wrong line, but yeah, I can, no, here it appears. Add exception to method signature. Okay. Well, sorry, I'm just lazy. I could of course have written that myself, but whenever you write something, you have the chance of introducing a typo like this. So whenever possible, I prefer to have my IDE help me and to have code written automatically by the IDE. That can save you from introducing bugs with typos, for example. Okay, so now this would be like fixed. But now the question is, what did it help us? We have here throws exception, we have here throws exception, and we have here throws exception. So 3 times we had to add this throws exception, and only because Java tells us this is a checked exception. But besides, we didn't handle it, which means what will happen when I execute the code and the default case is chosen, the exception will be thrown. It will bubble up to the top, to the main method, and as the main method doesn't handle it, the program will stop, and we will see the exception stack trace. Yeah, same thing we could do, for example, with the runtime exception. Throw new runtime exception. Also, in both cases, you can and you should add some meaningful message that tells us why the exception happened. So let's say unknown state and concatenate that with a given state. Okay, so now I can still keep it, but I don't have to. It's not obligatory anymore because this is not a checked exception anymore. Same here, I can remove all these and this. So now I have exactly the same code. The only difference is, I'm not handling the exception that my method signature doesn't get any longer. Because imagine, again, I'm always bringing this example, you have a huge program of hundreds of classes, and as soon as one method has that throws exception, this is really contagious, which means another method sooner or later will use the method that says throws exception, will then also have to say throws exception. This method again will be used, and sooner or later you will have that throws exception in each and every method. And then it doesn't help us at all. It just makes the code more wordy, let's say, and yeah, it's not really meaningful. So anyway, let's first of all provoke that exception that we see how such an exception stack trace looks like. For this to happen, I have to call the main method, and I have to give it some argument that we don't know yet. Okay, let's go here, run. I think I have prepared something already, edit configuration. And yeah, flying, parking, driving, A, B, C, D, E, F, G. Because also I wanted to show you, I've introduced the main method only in the prior episode. So here we have some valid states as well as some invalid states. Also in lowercase letters it should be invalid. And as we're iterating through the arguments in a for each loop, we should see, well, let's just do it. Actually, I still have to run it. And let's have a look what happens. Okay, so you see, the exception happened. Unknown state, flying. So I would assume the reason is that this happened for the very first time. The first argument was already flying. So this is our program stopped. This is the reason, because it's not handled. Now we could also handle it to show you what's the difference. Now the question is where to handle such an exception. Well, always as early as possible, like at the class that can do something about the exception. In our case, I just define that in the case that I get a wrong argument from when the program is called as an argument, I want this to be printed to the console so that the user knows. Which means, I want it to be printed here, which means the first place where I can handle this exception is only here on the very top. And so there is this new construct. I say try, which is like telling the compiler I know something evil can happen and I just want to try it. But now I can say catch, and I can catch this runtime exception. Usually, I don't like really short variable names because they're not readable, but in the case of an exception, because an exception block is always very, very short, the default is to call the exception with E for exception, and I think here this exception is okay because we won't do much with the exception, and the block will be so small that everyone knows the E is for the exception. Okay, so curly braces, and now we can do various things. First of all, we could say e.print stack trace. Well, this is actually exactly what we have here. This is the stack trace. The stack you can think of as a list of all the methods that were called in reverse order. So here you see main, process, from. Can also jump there. I mean, this doesn't hold true anymore because I've now added code, but at the time we executed this code and the exception was thrown, this told us exactly in each class where the exception happened. Well, here it's still true and here also, but in my car selector I have adjusted the code. By the way, about this, the fact that I've adjusted the code, also when you sometimes have a stack trace and you need to analyze where it came from, this is really often happening that the code that is running on production is older than the code that you develop on, because of course development continues, and then you can only find out the exact place where the exception happened if you keep the exact same code that you have running on production. Yeah, but this only really, I don't want to go into more details. This would be a topic on its own again about revision control. This is really a huge topic, but yeah, just that you know, the stack trace is really helpful if and only if you have exactly the same code that was implemented at the time this code was running. I mean that they're both in sync. Okay, so print stack trace here wouldn't make sense because in this case it's just a default anyway, but this can be used and is often used to log, for example. In, I don't know, was it episode 13 I think, I talked about logging, and so when you want to log an exception you can do it like this. This is usually how you do it. Well, I haven't got the log class here and I don't want to do it, log error or log one you would say. And this depends, error only when there is something that has to be done. For example, a database that has to be restarted. In other cases, probably one is also okay. Okay, message is the string that I added into the constructor of the exception here. And I have removed the stack trace because this is actually done inside of the log object, which I won't add now. If you want to know more about logging, have a look at my episode 13 where I explain logging in detail. Okay, so logging is one thing we can do, but in this case I say I don't want to log it, I want to directly print it on the console. I think also in the episode about logging I warned you not to do it, always to prefer logging, but in this case let's assume we have just a very small program only be used to run something from the console, and in this case it can be okay to just say system error dot println, which I also wanted to show you once, println for new line, and here then I can say dot get message, or I can also say e dot print stack trace, which doesn't make sense because we already have that. So to alter the behavior, let's do this. Okay, let's run it again. Now you see something else. You see the program hasn't stopped, but instead we see unknown state flying, unknown state driving, and unknown state A, B, C, D, E, F, G. Yeah, so all the invalid states were printed out without, we don't even see the exception anymore. And it's red because I used system error println. I could also use out println because this is a special channel only for errors. And this is printing in general. See, now it's white. But really, I still warn you, don't overuse system out or system error println. because yeah, you can't configure it like you can configure logging. So in 99% of the cases, using a logger is better. Anyway, so let's have a look at the code now and think, is this really nice now? We have a for loop, we have a try, we have a catch. You see a lot of different hierarchies, a lot of different levels that we have to understand. And this is something I really don't like. This makes the code quite complicated. Okay, so this is something you should try to prevent. And anyway, I can also alternatively show you we could do exactly the same if this was throwing an exception. The only difference is that if we're not handling it, we have to add the signature, throws. So yeah. Maybe also I should now show you the alternative. If we don't want to add the method signature, the exception signature, we can directly in here say catch and then handle it. And then, I mean, handling an exception does not necessarily always mean you have to print it. I mean, printing it doesn't really solve the exception. It might be even better to really have a method that does something about the exception, and which I call now handle the exception. The only problem with that is, and I'm not implementing the method now. And this is what I said before. The case that you're really able to do something about the exception, which in this case, I mean, what could we do? If the user typed in something wrong, there's not much we can do. Well, there is one thing. We could, for example, ask the user to type in, to fix the state he typed in. But this we couldn't handle here. So again, if we want to like ask the user to do something about it, I would instead validate the state. So let's remove all that. Let's, for the time being, I add the runtime exception, but I will change it very soon, because now instead I want a validation added. And this can be done in the following way. I remove all that try catch. Instead, I say validate argument. And now I can implement that method. Create method validate. My IDE helps me again. No. Well, actually, I want to say is valid with a Boolean returned. Okay. Now you see, this is also interesting, by the way, about the main method, because this method is static. Also, this method automatically is static. So, because when this method is static, a static method cannot call a method that is not static, because an instance method can only be called when there is an instance. But for the main method, we won't create any instance of car selector. So for this reason, this is static. And it's private because we don't need to call it from outside, only the main method will call it. Now, how can we validate it? Well, for example, we could use a method directly provided to us from the enum class, and that is value of. This is not implemented by us, but it's implemented like automatically when they invented the enum in Java. This is one method that you get for free. So this will directly try to convert your string to an enum. So here I can say car state. So this actually does exactly the same thing like our switch did. So actually we won't need it anymore very soon. The difference to the method that I implemented is, or well, I did it actually also like this, when the conversion doesn't work, this will throw a runtime exception. I think because there are different types of runtime exceptions, and I think it will be an illegal argument exception to tell us the argument that you are giving to me, sorry, is invalid, but still it's a runtime exception. So, and because this will throw an exception, we have to add the try catch block here because we want to handle this. Try catch, and then I say runtime exception E, or I hope I'm right, I can directly say invalid argument exception. There it is. I think that should be the one. If not, we'll see it because the exception will not be caught. Okay, and in here we can just return false without logging anything. No, see, this is the wrong one because we can't catch an exception that is never thrown. So invalid, let's see what, delete catch. No, this is not what I want. Maybe it's an invalid state exception. Yeah, this works. So see, this is also how you see this value of may throw an invalid state exception if the argument given is unknown in case of, for example, flying, driving, ABC. Okay. And to be honest, I think this is also not optimal that we only have this value of method. I think it would be much nicer if the enum base class would directly provide a is valid method, just returning true and false. But again, seems like the inventors of Java didn't listen to my opinion. I'm just making a stupid joke. So for this reason, we do have the exception, but we are able to convert it. So because we're converting it directly, the exception doesn't pollute our whole system. Let's say it like this. And we can now say here, return true, which we could also put at the end of the method. This is exactly the same. Yeah. So wherever you have it. So, and this is also the jump. I mean, imagine you could have lots of other code like system out printlns, or just print something. So you could have many more lines that would do lots of stuff. Let's just copy and paste that to show you many more lines. We could even reassign car state to something else. Let's just say null. So what happens if this line of code doesn't work out because the argument is unknown, for example, flying? When the code is executed, the execution will jump from here directly into the catch. So this is leaving the normal program flow. The normal program flow would go from line 21, 22, 23, 24, 25, and so on. But here we're jumping from line 21 to line 28. Yeah, and this is helpful because, for example, imagine we have done this several times. For example, also here and there, even maybe in sub-methods. Then we have just one catch that would handle all these different places where an invalid state exception could happen. That's the idea of exception handling. Okay, just to give you some more details. Actually, I don't even need that, so I would remove it. We're only like abusing that value of method to have the information, is that valid or not. Okay, and now I can react on that. I can say if not valid, or I can say only process it if it's valid. Well, yeah, maybe let's do this, because you saw already how the invalid states are printed. Now let's do something else. Let's only process valid arguments. The question, of course, is, does that make sense? Now we wouldn't even realize we have a problem in our code. So maybe we should also say else print that we have a problem. System error dot print ln invalid argument given, or let's say ignoring invalid argument. So this, by the way, whenever you log, I think I'm now repeating myself because I already talked about logging, but I can't say it often enough. Always add as many arguments as possible so that whoever is responsible for a problem knows why this happens. Otherwise, yeah, it's really hard to understand why something doesn't work out. Oh, now we still have an illegal argument exception. How is that? I don't know, and this is interesting because we can now check. Like, this is what I told you. It's in car state. There's we still have the from. It seems like we called it somewhere. But no, I'm wrong because this says in line 5, so this is not it. Car state illegal. This is why. See, I was wrong. This is the invalid state exception, and what is actually thrown by Java is the illegal argument exception. So see, this is actually what happens. Nice that we see it. No enum constant flying. So this is what Java gives us. It throws an exception, and this now we will catch. Okay, let's retry. See, this is how everyone introduces bugs, and this is why we need tests. Today I'm not doing a test because I just want to show you exceptions, but yeah, we do need tests. Tests are very important. Okay, now it works. See, ignoring invalid argument, flying, ignoring invalid argument, driving, ignoring invalid argument, A, B, C, D, E, F, G. And the valid argument was processed. It just didn't do anything, which of course we can change. Here we could say system out print ln. Again, this thingy here is evil. Only use it in very rare situations. Yeah. And I can say valid state car state. Execute it again. Yeah, so you see 3 invalid states and 2 valid states. Okay. So, of course, I mean, this was just an example. Normally you would have some method doing something about the state. Further do something with the car state. I mean, I'm just making this up because all I want to explain you is exception handling, but I hope you get the idea. So anyway, there's one more thing, and then actually I would like to shortly recap the important points of exception handling. And the missing thing now is, oh, by the way, let's remove the from, because I showed you we don't actually even need this anymore. Okay. Because what you can also do is finally, this is very important, not in our case now. I'm just making something up. Finally. As the name implies, this is done finally, at the end. No matter if an exception happened or not, this block will always be called. And this is important when you have resources, when you have input-output operations, or in short I/O, which you have if you communicate with a database, if you read something from a file, from your hard disk. Yeah, something like this. Because when you read something, especially from external systems, who can tell you that the external system is actually available, or the hard disk could fail? And so with I/O operations, there's always nasty stuff that can happen. But there's one important thing, which is for I/O operations you need resources, and so you have to close them in any case. Otherwise, you really could have a problem with more and more resources lost. So yeah, this is a big topic. I can't explain that in a second, but all I want to tell you for now, this finally is very important when you deal with I/O operations that might fail. And in this case, you can close these resources. And close resource. For now, I'm just giving you my resource, this stupid method. You can implement that yourself, but also there are very cool helping utility classes found on the internet, open source, like for example IOUtils. Oh, it already finds something, but this is not the one I mean. The one I know of is, for example, I think from Apache, and they would have something like close, I think silently or so, close resource. And then this will do all the nasty stuff for you. Okay, I'm stopping here. What is important is, and this I want to show you just by printing something, system out println, and I will throw the exception again, which means what you can also do is you don't even have to catch it. This also works. Try and directly finally. Okay, formatted the code. So now with the invalid argument, our program will be stopped. Execution will be stopped. But in any case, let's say I am still running. And I can also show you this line will not be printed after exception. Well, it might be that this runs once if the first argument is a valid one, because with the string array, we never know for sure the order. It's not guaranteed. But so that you see, I would, whatever happens for this will, for every time we call is valid, this will always be printed. So let's see what happens. Okay, oh, something's still wrong. Not found, yeah, because we have removed the from. Yeah, sure. So let's for now remove that. We at the moment don't need it. And see, this is again the reason why we need tests. I'm really doing some nasty hacking at the moment. Okay, and you see, I'm still running. And then the exception comes. So this is what happens when the exception happens. We didn't catch it, so we see the stack trace instead. But I'm still running is printed before that. And this is the place where we can do some cleanup operations like closing resources. But you could do anything in here, basically. Same thing if we catch it. Catch, now I say runtime exception. Runtime exception, because it's also a runtime exception. We should talk about inheritance very soon, so that I can go in more details why that is so. Now what is wrong? Yeah, we need the closing curly brace. And one less of this. So now I can say, oh, maybe this time I will also show you print stack trace. So this should actually do the same. And I will say system out println hello again. So you get an idea. In finally block. Okay. Ooh! No, something weird happened. And this is for all the invalid states, flying, driving, the stack trace was printed and it's red because, yeah, it's the print stack trace, so it's printed on system error. Okay. And you see, this is the illegal argument exception, the first one, the second one, and so on. And you see at the end, hello again, which comes after the whole stack trace. Yeah. And you also see this line will not be printed after exception because it seems like, I mean, we had different arguments in here. So for the valid ones, this line was printed. And you see also, I mean, now I'm really having a hard time knowing why this happened. So again, I violated my own rule. I didn't add the argument. So here I can say argument. I say valid argument. Yeah, because if it's after the value of, if this is printed, it means the exception did not happen. Now let's call this again, and let me also remove the stack trace for now to make it a bit more readable for us. And let's run the main method again. Okay, see, now it's more readable. So what do we have here? Hello again. So the runtime exception happened, and again, I did not add the argument. In this case, I can also say get message, which gives us the message of the exception. I'm not sure if our illegal argument exception has a message, but we'll try this. Yeah, see, this is the message. Hello again. And the message is no enum constant, Marcus Beal car state flying. So now you see, you can understand the problem so much better. And after this, we are in the finally block. Then comes the valid argument parking. In this case, we're also ending in the finally block. Then comes a second valid argument. We're also in the finally block. Here again comes an invalid state, driving, but we're also in the finally block. And the last invalid state also in the finally block. So the finally block is always executed. Okay, I think this pretty much rounds up everything I wanted to tell you about exception handling today. Now, because this was quite a lot, let's go shortly through the most important gotchas. Okay, so in Java, there are runtime exceptions, which are unchecked exceptions. Unchecked means they are not enforced by the compiler to be handled. You can just throw them, and also Java will throw them for you. For example, a very famous or infamous exception is the null pointer exception. You should never throw that yourself. Java will throw that for you if you try to access something that is at the moment null. Just null pointer exception is probably the most infamous exception because when it happens, you will not be very happy. Okay, so unchecked exceptions are runtime exceptions, and they can happen at any line because any line can also be null, and they don't have to be handled in code. If they're not, then in the worst case, the program will stop, like we saw before, because the exception will bubble up all to the top. And if it's not handled in here, the program will stop and it will by default print the stack trace. Then Java was the first and actually also the last programming language that introduced checked exceptions. Checked exceptions are exceptions that are enforced by the compiler that you do something about them, or you add a throws with the exception name in your method signature. There are various checked exceptions. One of the most famous ones is probably the IO exception. That will be, see, it's in Java IO, the package. This one will be thrown if you have any problems with IO operations, which is again a topic on its own. Okay, and I said Java was also the last programming language that introduced checked exceptions. So this really shows us, indicates us that checked exceptions were not so smart, because you see, all they help us in the end is they add noise to the method signature, and the case that to use them for cases that you can handle them, well, I say if you can handle them, why not taking care of the problem beforehand, for example by using validation. Validating the case, the given argument, and then handling that without actually even throwing an exception. And then, maybe last but not least, for every rule there's always an exception. We saw that, now I've removed it, unfortunately. Yeah, let me go back. We saw that with the switch on the string, where I said in a prior episode, don't do that. Well, I did it here. And we also saw that here, where I use the value of method of enum, which throws an exception, and I said, well, we're trying to validate it, so if we are validating it, we don't need the exception. It's just that we can't do anything about it, how the method was written by the inventors of Java, so we just have to live with that sometimes an exception is thrown where we would just validate it. But what we can do is, we can catch the exception and then return true or false, for example. So we can convert the exception into a valid return value. Also, there is a hack. If you have a library, like an old library that would still throw a checked exception like an IO exception, what you can always do is you can wrap, we say wrap, a checked exception into a runtime exception. And this is like this. Let's create a my IO exception. Let's create an IO exception shortly. So see, you can also just create them like any other object. And now on that exception, well, it cannot be called E because we already have that. I can now say throw new runtime exception. And I can give it the IO exception. And this is why we wrap it, because we put this exception into the constructor of runtime exception, which means this is the wrapper. It wraps around the other exception. And now our compiler will be fine, because we're not throwing an IO exception anymore, we're throwing a runtime exception. Well, this is a nasty hack, but I think it's still better than having checked exceptions all over your code. And yeah. Okay, so now let's stop here. I guess I could continue forever because there's so much you can tell about exception handling. I hope you were able to follow my explanations. As always, I would be very happy if you could like the video in YouTube on the bottom right corner, or you can also subscribe to my YouTube channel. And yeah, thanks for watching and see you next time.